Alright, today you're learning about lateral area and surface area of prisms and cylinders. Okay, so first thing you need to know is lateral area happens to be the sides that go around your three-dimensional figure. Bases are the ones that are on top and on bottom, and the way I like to think of it is however you name your shape, that's what your base is going to be. So if you take a look at this net, which is a 2D representation of your three-dimensional figure. You see how we name it by the hexagon? Well, the hexagon happens to be your base. And if you take a look at these rectangles, that's actually the lateral bases. Last thing on this page you need to know is the difference between a right prism and an oblique prism. Right prism means it's perpendicular to the ground, so the height is straight up and down. Oblique means it's kind of lopsided and it's not exactly straight up and down. Okay? Alright, so two concepts you need to know. Lateral area, you're going to take the perimeter of your base, so P stands for perimeter of base, and the height actually stands for the height of your prism. So that means you're going to take the perimeter and then multiply it by the height, and it will actually give you your lateral surface area. Okay, so if you look at surface area, that means you're going to actually add in your two bases plus your lateral area. And where this formula comes from, basically they just took 1/2 AP, which is the area of a regular polygon, and they plugged it in for big B. Well, the 2's cancel out, so that's where the 1/2 AP, or that's where the AP comes from. Lateral area we know is perimeter times height, so that's where they got the pH from. Alright, so let's go to our first example. Alright, so we're going to find the lateral area and surface area of a right pentagonal prism. First thing I want to do is just write down my formulas. So L equals pH, and surface area equals AP plus pH. Okay, so now that I have my two formulas down, I'm going to identify the unknowns. Okay, I do actually know the height of my prism. I see that it's 9. Okay, but I don't necessarily know the perimeter just yet. Okay, so I know the perimeter goes all the way around my base. I see that my side length is 7.05. So what that means is I'm going to say, since I have 5 sides, I'm going to multiply that by 7.05, and that's going to give me 35.25. And now that I know what my perimeter is, I'm going to be able to plug this in for P. Okay, so I actually have enough information to plug into my lateral area. So lateral area is equal to 35.25 times 9. And when I plug that into my calculator, I get about 317.25. Okay, so that's actually feet squared as well. So we found our lateral area, and now we need to find our surface area. We have our perimeter, and we have our height of our prism. The only thing we don't have is our apothem. So if you take a look at this triangle here, it's actually this piece of my picture blown up so you can see it. Well, we know that the side length is 7.05, so if we cut that in half, that's where you get the 3.525 from. And you can do Pythagorean theorem, a squared plus b squared equals c squared, to get your apothem. Okay, so that's actually a squared plus 3.525 squared is equal to 6 squared. Alright, when you actually solve that, you get your apothem to be about 4.9. Now you have everything that you need to plug into your surface area. So surface area is equal to 4.9 times 35.25 plus, and actually your lateral area, you can just plug that in here since you already did perimeter times height, so 317.25, and when you plug that entire equation into your calculator, you end up getting about 488.40 feet squared. Alright, let's move on to cylinders. So it's the same concept. The lateral area is going to be this orange part here, and then the bases are actually circles this time. So we're going to take 2 pi r, which is the circumference of a circle, or the fancy name for perimeter, times our height. So it's pretty much the same thing as a prism. And then our surface area is going to take our 2 bases plus our lateral area, which we can actually replace that with pi r squared for our base area. So our surface area formula for a cylinder is 2 pi r squared plus 2 pi r h. One other thing, a right cylinder means it's standing straight up and down. Oblique cylinder means that it's going to be kind of lopsided. Okay. Alright, so for our first example, we need to find the lateral and surface area of the right cylinder. We'll start with the lateral area. And we know that the lateral area of a cylinder is 2 pi r h. Alright, so we need to locate our radius, which is 4, and we need to locate our height of our cylinder, which is 8. Okay, we have everything we need to do to plug in. We have 2 pi, our radius is 4, height is 8. 2 times 4 times 8 is 64 pi, and then of course if you plug that into your calculator, it's 201.06, and the units on that is meters squared. Alright, so that's our lateral. Now we need to find our surface area, and if you recall from the last slide, our surface area formula is 2 pi r squared plus 2 pi r h. And we actually just found this piece up here, so we're just going to plug in what we found beforehand for this entire expression. Okay, so we know that our radius is 4, so our surface area is 2 pi 4 squared plus 201.06. And you can actually go ahead and plug that into your calculator, and you get about 301.59 meters squared. So that's your total surface area. Alright, this brings us to example number 3, solving a real-life problem. You're designing a label for a cylindrical soup can, and shown the label will cover the lateral area of the can. Find the minimum amount of material needed for the label. Well, the label goes around the can, okay, so we need our lateral area. And the lateral area for a cylinder is 2 pi r h. Okay, so the first thing we need to know is our radius, and here we're given the diameter. So if we take 9 divided by 2, that's going to give us 4.5, and that's our radius. Okay. Then we need the height of the cylinder, which is 12. That's going to go in for h. So actually we have everything we need to plug in. L is equal to 2 pi, radius is 4.5, times our height, which is 12. And if you plug that into your calculator, well, if you take 2 times 4.5 times 12, that's going to give you 108 pi, which is about 339.29 centimeters squared. Okay, so you actually need a minimum of 339.29 square centimeters of material. Example number 4, we're going to find the lateral area and the surface area of the composite solid. Alright, so to find the total lateral area, we have to think to ourselves, okay, so we need the lateral area of the cylinder, okay, plus we need the lateral area of the prism inside. Okay, so I'm just going to say lateral area of cylinder, lateral area of prism. Okay, so you have to think about your lateral area formulas. Well, the lateral area, I'm just going to say total lateral area, TLA, like this. Lateral area formula for a cylinder is 2 pi RH. And the lateral area of a prism is perimeter of your base times the height. Okay? So if we take a look here, we know that our radius is 6. We also know that the perimeter of this base here is going to be 4 plus 4 plus 3 plus 3. Okay, which is 14. Okay, we know the height of both of these is going to be 12. So we actually have everything we need to plug into our formula. Okay, so our lateral area is 2 pi, radius is 6, height is 12, plus the perimeter of our base of our prism is 14 times the height of the prism, which is 12. And when you plug that into your calculator, it's 620.29 meters squared. Okay, so that's the lateral area. Okay, now we need the surface area. Alright, so the total surface area is actually going to be our lateral area of our shape. And we're going to have to add in our two bases. Well, if you take a look at our base, we have a circle and then we have a rectangle cut out of it. Okay, so we're going to take 2 times area base of cylinder, and we're going to subtract out the area base of the prism. So previously we already found the lateral area. So surface area is equal to, and we found that to be 620.39 plus, we're going to say 2 times, well, the area base of the cylinder, which that's a circle, so pi r squared, so pi r, which is 6 squared, and we're going to subtract out that rectangle, which we know is 3 times 4. Okay, so if you actually plug this all into your calculator just how you see it, our surface area is going to be about 822.58 meters squared. Alright, this brings us to our last example. We're going to talk about changing dimensions in a solid, and we're going to describe how doubling all the linear dimensions affects the surface area of the right cylinder. Okay, so before the change, if we think about our dimensions, we have a radius of 2 feet and we have a height of 8 feet, so I'm going to go ahead and erase that. And after the change, if we double our radius, so 2 times 2, that's going to give us 4. And if we double the height, that's going to be 8 times 2, which is 16. Alright, so let's actually plug this into our surface area formula. Alright, so surface area before the change is 2 pi RH plus 2 pi r squared. Okay, 2 pi, we know our radius is 2, height is 8, plus 2 pi 2 squared. So we have 2 times 8 is 16 times 2 is 32 pi plus 2 squared is 4 times 2 is 8. So our surface area is actually 40 pi, or that's about 125.6. Okay, well, if we do the surface area of after the change, we end up getting 2 pi times 4 times 16 plus 2 pi 4 squared. 16 times 4 is 64 times 2 is 128 plus 16, because 4 times 4 is 16, times 2 is 32. So if you take 128 plus 32, you get 160. So 160 pi, which is about 502.4. Now, if you think about the scale factor of what that does, you need to compare your new over your old. Okay, so our new surface area was 160 pi, so 160 pi divided by our old, which was 40 pi. Well, the pi's cancel out, and then you take 160 divided by 40, which is 16 divided by 4, which is just 4 times as big. Okay, so our scale factor for changing the area, the actual solution is 4 times as big as the original figure. Okay, so the surface area changes by 2 squared. And that's it for your video. That's a quick lesson over surface area of prisms and cylinders.